This video has sound. Hopefully everyone is hearing my voice. Otherwise, they're watching me point at this sign and hopefully getting their sound going. This is a lesson on 11.4, Chapter 11, Section 4, out of the Geometry Chapter 11 Study Guide. Now, in the previous section, we talked about the measure of an arc. The measure of an arc has to do with the angle that the arc makes. So, for example, if this little section is the section we're talking about, the measure of the arc would be how many degrees this is. So it might be, 70 degrees, for example, for this one, from here to here. The arc length is not a measure of the angle. The arc length would be a measure of the outside of the circle from one side of that angle to the other. So it might be a measure of yards or feet or inches or millimeters or whatever. But it's a distance around the outside of the circle that's not the whole thing. That is the arc length. It's a section of the outside of the circle. So circumference is the distance all the way around the circle. Whereas an arc length is the length of one part of the circumference. Okay, so circumference has a formula that can be written a couple of ways. It can be written as pi times the diameter of the circle, diameter being the distance all the way across. That's d. Or, since the diameter is the measure of two radii put together, you could say that it's 2 times the radius times pi, or in other words, 2 times pi times radius. Same thing. Okay. So, I don't know why they want us to rewrite these formulas, but okay. Let's try an example. If the circumference of a circle is what they want us to find, and they've told us that the radius is 11 meters. Circumference is 2 pi times the radius, so that would be 2 pi times 11. Which gives us a circumference of approximately 2 times pi times 11, 69.1. Now, please, when you're using your calculator, use the pi button. Every calculator, except for extremely simple calculators that just have adding, subtracting, multiplying, dividing, if it has more than just that, you should have a pi button. Please use the pi button. If you don't use that, you're going to come up with answers that are not quite right, and they may be marked wrong on the quiz. So please use your pi button. If you don't have a pi button, and again, this is very rare, use several places of pi. If you want to use pi, an approximation for pi, you can use 3.14159. You can see I'm using 5 places after the decimal. That is important. Don't just use 3.14. because you're going to come up with answers in some cases that are way off because you needed more of those numbers to get an exact or a more appropriate answer. Okay, so in part B, they want us to find the radius, but they give us the circumference. So if we're using the same formula, and we know that the circumference is 18, can we find the radius? Absolutely. So if I divide both sides by 2, and then divide both sides by pi, the radius turns out to be approximately 2.86 yards. Now this one talks about diameter. They want us to find the circumference if the diameter is 23 inches. So I'm going to use my alternate formula, that the circumference is pi times diameter. And they say that since the diameter is 23, I'll substitute that in here. So pi times 23 is 72.26 inches for the circumference. Remember, circumference is not area. Area is a measure of how much surface you have. Circumference is just a measure of length or distance. You're measuring like with a measuring tape or a ruler. You're just measuring in a circle rather than a straight line. So that's just regular inches or meters or whatever unit you happen to have. Number 3, find the radius. They give you circumference here. Big C means circumference of 65.98 centimeters. So if circumference is 2 pi r, again they want me to find the radius, so I chose this formula as opposed to the other one. So circumference being 65.98, I would have 2 pi r equals 65.98. So I'm going to divide both sides by 2. And then divide both sides by pi. So the radius ends up being approximately 10.5 centimeters. Now, the next problem is one that students tend to get quite confused about. I think it's because we've been talking about area for a while, and so they have this concept of how to find area. And really, perimeter is different than area. Perimeter is the distance around the outside of the shape, whereas area is the amount of space inside the shape. So, perimeter is what we're focused on right here. What I'm going to do is I'm going to say that I have 2 different types of lengths. I have straight side lengths, and then I have a curved side lengths. I have 3 straight side lengths, and I have 1 curved side length over here. See that? Now, since this is 5 millimeters here, then this would also be 5 up here. So this distance across here would be 10 millimeters. Now, that's not part of the perimeter, is it? Because this is not part of the outside edge of this shape. But it does tell me how big this is. If this is 10, then this would also be 10. And since this is marked congruent with this and this, then this would be 10 and this would be 10, right? So out of the 4 sides of my shape, I found 1, 2, 3, and now I simply need to find the last side. This last side is part of a circle. It's exactly half a circle. So if I can find half of the outer edge of the circle, which is the circumference, and I'm running out of space, write it into the coordinate there. That's what I would need. I would need not the whole distance around a circle, but just this half portion length from one side directly over the other side of the circle. So if the full circumference is 2 pi r, but I only want half of that, then I would do half of 2 pi r, right? Half of 2 is 1. 1 times pi times r is just pi r. So this half of the circumference, I can just multiply pi times the radius to get that measurement of distance from here walking around over to there, so to speak. So that would be pi times the radius of the circle, which from the center of the circle to the edge is 5 millimeters, which gives me approximately where am I here? 15.7 millimeters. Now, doesn't that make sense? If this distance from here to here is 5 millimeters, wouldn't it make sense if I went from here all the way over to here that length would be about 15.7? I think so. So, okay, now to figure out the perimeter, that means the distance if I went all the way around the shape. I have this section right here, which is 15.7 from here to here, and then I have 10 and 10 and 10. So if I add up the total lengths around the outside, I have 10 plus 10 plus 10 plus 15.7. So I get an approximate distance around the outside of 45.7 millimeters. Okay, now the last two examples, they want us to find how far does the wheel travel, this is our wheel on a skateboard, when it makes 35 revolutions. Well, basically, if it went around once, it would travel the distance that would allow the wheel to touch the ground at every section once. So basically, as it rolled across the ground, it would touch here and then 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 all the way around. That's one revolution, right? So each section of the outside of the wheel would be able to touch the ground once when it rolled around once. One revolution, right? So that would be how far it would go if it could only roll one time around, right? Would be this distance here. So if I can figure out what one circumference is on this circle, then I can figure out how far it would roll across the ground in that amount of space, or that length. And that would be the same as one revolution. And then if I multiplied that distance by 35, that would be how far it would go in 35 revolutions, or 35 spins around. So it looks like this entire diameter here is 20 plus 15 plus 20, which is 55 for the diameter. So to find the circumference, or how far this wheel would go if it could only spin around once, that would be pi times the diameter, which is approximately 172.8 millimeters. Now, unfortunately, they want to figure out how far we're going to travel in meters. So at some point we're going to have to do a conversion. Either we can convert this to meters, or we can find the total distance that it would travel in 35 revolutions first, and then convert that answer to meters. I think that's what I'm going to do. So this is how far this wheel would travel if it could only spin around one time. That's called one revolution, because that's allowing the wheel to touch the ground only once all the way around. And that distance around the outside is 172.8 millimeters. Now, the total distance is 172.8. That's if it only spins around once. And they're saying, what if it spins around 35 times? That's 35 revolutions. That gives me approximately 6,048 millimeters that it travels. Now, a millimeter is not very much. A millimeter is about as thin as one of my lines. Like it's as far apart as you can hold your fingers without touching. That's how tiny a millimeter is. So it's not really far, but 6,048 millimeters, you can kind of maybe get a sense of how long that is. Now, they want to know that's how far we've already figured out that that's how far the skateboard would travel if the wheels spun around exactly 35 times. But they want this answer in meters, so what I'm going to do is I'm going to convert that to meters. I'm going to use a unit conversion fraction. I know that for every 1,000 millimeters, I get 1 meter. So this unit conversion fraction allows me to cancel the millimeters, multiply across the top. 1 times 6,448 is 6,048. On the bottom, I just have 1,000. And then if I divide, I get about 6.048 meters, but they want me to round off to the nearest meter, so that would be about 6 meters. Now, I'm going to let you try the last example on your own. Actually, oh, I have to keep going, don't I? Okay, so I'm just going to show you this next one. It's very similar to this one. This is my solution to number 2. You might want to pause the video if you want to write all this down. Pause now. Okay, next page. So now we're going to be talking about arc length. As I mentioned, arc length is the measure of distance around the outside of the circle, whereas arc measure is a measure of degrees of that section. So you can see in the formulas here where they say arc length of versus m. You see the m there? That means that this arc, if I measure it in degrees, m, that's degrees. Whereas if I say arc length of, then I'm talking about the length between A and B as a measurement of distance from here along this curve over to here. See the difference? Okay. So, you've got a couple options for the type of formula that you want to use. I prefer the second one. So that's the one I'm going to use in my examples. Your teacher, if this is another student's or teacher-student in geometry, might use them both or might prefer the first one. I'm going to try to be a little consistent with my examples. I'm going to use the same type of formula every time. Okay, so the arc length, so that's the distance from here around the curve over to here. Okay, so in this diagram it might be, you know, I don't know, 50 millimeters, or it might be a few centimeters. So whatever that is, that's this. That can be calculated by taking the entire circumference of the circle, that's this, 2 pi r, do you remember that as the formula for circumference? And what they're saying when you multiply something by a fraction is you're saying, I don't want the entire circumference, that's this, I just want a little piece of it. And this fraction allows you to take the part or the portion out of the circumference that you want. So when we take the degrees of measure of our arc and divide it by 360, it gives us a decimal that's less than 1. And when we multiply that decimal by the entire circumference, we're basically taking that percentage, or that portion, if you will, out of the circumference that gives us just that one part of the edge of the circle. So here, if I want to find the arc length of AB, I want an 88-degree portion out of the 360 from the full circumference of 2 pi r, which is 2 pi times 2 in this example. So if I take 88 and divide it by 360, and then take that number and multiply it by 2, and by pi, and by 2, I get approximately 3.07 meters for the distance of this arc from here to here. 4 pi is bigger than 12, And so if that's the distance all the way around the circle, does it make sense that this would be 3? Four pi is about 12.6. So if the distance around the whole circle is 12.6, does it make sense that just this part would be 3.07? Yeah. So you can kind of compare this answer to the full circumference to kind of get a sense of whether it looks right. Here, they don't want the length of the arc. They want you to find the measure of the arc. You see the little m here? That means they want you to find the amount of the angle. So, this is, let's see here. 12.3 feet is actually the radius. The radius is 12.3 feet. And then 38 feet is the arc. So that's the distance from here to here. Okay. So what they want us to do is figure out what this angle is over here. And it might look like this is a straight line, but it's not. It's close to 180 degrees, but not quite. So I'm going to use my formula that says that arc length equals your angle, the measure of the arc, divided by 360, times big C, which is circumference. So they're telling me that the arc length here is 38. The measure of the arc is what we're trying to find. And the circumference is 2 pi r, the radius being 12.3. Okay. So if I have 38 equals the measure of the arc over 360 times 12.3 times 2 times pi, so 2 times pi times 12.3, I get about 77.283 approximately. And then what I'm going to do is I'm going to take that and divide it by 360. So I get 0.214675 times the measure of the arc. And then in order to solve this, I'm just going to divide on both sides by this decimal. So the measure of the arc they want me to find is the measure of, technically it's measure of RFs here, is approximately 38 divided by that decimal, 177 degrees as an angle measure from here over to here. I'll give you a second to finish writing that down. Number 3. The length of AB goes from here over to there. And remember that arc length, we want to actually measure how far it is in feet from here to here. The measure of the arc is in degrees. They already gave that to us. That's 97. So, for number 3, the arc length equals the measure of the arc divided by 360 times the circumference of the circle, right? So if we want to find the arc length, that would be 97 degrees out of 360, and then the circumference would be 2 pi r. So if I take 97, divide it by 360, take that answer, multiply it by 2, and multiply by pi, and multiply by 4, I get approximately 6.77 feet. Now remember, this is the circumference. This is all the way around the circle, so this would be 2 times pi times 4. So according to my calculations, if 2 times pi times 4, same as this, is 25.13, that's the distance all the way around this circle once, is 25.13. Then does it make sense that this section here would be 6.77? Does that seem like the right proportion out of the 25.13? I think so. So that does seem like a reasonable answer to me. All right, we're going to come back to number 4. Let's do number 17 next. Number 17, I'm going to use some of the space for number 4. Okay. So number 17, they want us to find the measure. See the M here? That means they want us to find the angle in here. So we're going to use the same formula. Arc length equals the measure of the arc in degrees divided by 360 times the circumference. So this is what they're asking us to find. We know the arc length is 23.88. We don't know the measure of the arc in degrees, but we can calculate the circumference because that would be 2 pi r, so 2 times pi times the radius here has been marked as 12. Okay, so what I'm going to do is I'm going to take 24 pi, I'm going to multiply 24 times pi, and then I'm going to divide that by 360. And I get this decimal, 0.20943995. So that's the numerical parts put together, and then here's your unknown. So all I have to do basically is divide both sides by that decimal. So the measure of arc AB is 23.88 divided by 0.20943995, and I get approximately 114 degrees. Now does this look like 114 degrees? If half a circle is 180 and maybe this much would be 90? Yeah, that does look like 114 degrees to me. So that seems like a reasonable answer. Alright, so this is a conveyor belt if you've ever been to the airport and then had to pick up your luggage in the baggage area. Basically they spit out your luggage from a chute that spits out your luggage, and then the luggage kind of goes around in some sort of a rounded shape. It's not always necessarily a perfectly rounded circle on each ends like this, but basically this is a luggage conveyor belt where you can pick up your luggage. And it says that on this side, basically this is half a circle over here, and this is a perfect half circle over here. So it says that the radius of these circles is 8. And they want to know if you stick a coin on the outside edge of this conveyor belt and the coin travels around the outer edge one full time, how many feet would it go? Well, obviously, if it goes from here to here, that's 20 feet, or from here to here, that's 20 feet. So we just need to figure out how far it would be around here and how far it would be around there. Well, basically, if you take these two pieces together, don't you have one whole circle? I think so. So what I'm going to do is I'm going to find the circumference of the circle as you go around this half plus this half. So that would be 2 times pi times the radius of 8, which would give me 16 pi, which is approximately 50.265. That is if you travel around the outside edge of this top part and the outside edge of the bottom part, because that's one full circle circumference. Then I'm going to add, to find the entire perimeter all the way around, if you travel around this once, it would be the circle part plus the 20 plus the 20. So 20 plus 20 plus 50.265 gives you about 90.265 feet, and they want us to round off to the nearest foot. So that's about 90 feet that the coin would travel if you set it on the outside edge of this conveyor belt.